This video provides an introduction to the ICD FlexFit Scleral Lens. In as brief a period as possible, you will understand the fundamentals of lens construction as well as the primary fitting considerations that you need to make through the diagnostic process. The ICD FlexFit is exclusively available in Canada through Precision Technology and Cardinal Contact Lens. My name is Randy Kojima. The ICD FlexFit was designed to fit virtually any eye shape, from the most oblate post-refractive surgery patient through normal corneal shapes with ocular surface disease, through keratoconic eyes, and exceptionally bulging post-graft patients. There's a lens in the trial set that will have the right height for you to fit that eye. The ICD FlexFit is a vaulting scleral lens, meaning your goal is to clear the central cornea, clear the peripheral cornea and limbus before landing the lens out far on the periphery on the sclera. You use the more symmetric nature of the sclera to create a stable landing for that lens, and then you vault through all the irregularity in the middle. And that's what makes these lenses relatively forgiving, because we don't have to fit the most challenging part of the eye. We use the more regular scleral shape to work to our advantage and just clear over top of everything else. Now, what makes the ICD FlexFit different from anything else? One of the considerations is the use of multiple tangents. There are various zones that use straight line or angular surfaces to best match the underlying peripheral cornea, limbus, and sclera. This creates a lens that's exceptionally forgiving in its fit and creates as well a very high first fit success rate. The ICD FlexFit Diagnostic Set has two diameters of lenses, a 14.8 for the more regular in shape or lower in asymmetry eye, and a 16.3 for the larger eye and the more asymmetric surface. When in doubt, use a bigger lens. Bigger lens will have an easier time vaulting the cornea, easier time vaulting a larger eye as well. The smaller 14.8 can be helpful when you've got a deep set eye, when you've got a patient that's struggling with application or removal, or you have a very small cornea and low amounts of asymmetry. Now, in terms of using the smaller or larger, what other considerations should we make? And that's visible iris diameter. If you have a small 10.5 visible iris diameter, you can add 3.5 millimeters, and that gives you perspective on the appropriate diameter of ICD FlexFit. So 10.5 plus 3.5 millimeters would equal 14 millimeters. Easily a 14.8 millimeter diagnostic lens should work for that patient. However, if you have a 13 millimeter visible iris and you add 3.5 millimeters to that eye, then your starting lens should be somewhere around 16.5 millimeters. So there's no way a smaller diameter of 14.8 is going to fit such a humongous cornea. So consider that visible iris diameter factors in as well. Smaller corneas can be fit with a smaller lens. Larger corneas will need a larger lens in order to clear the peripheral corneal tissue and the high points in the peripheral cornea that might exist. Now, in the smaller diagnostic, the 14.8, there's numerous limbal clearance zone scribes that indicate to you when you need to go larger in lens diameter. So the 14.8 millimeter diagnostics have these 6 scribes that run all the way around the periphery, and they denote the width of the limbal clearance zone. If those scribes are 100% within the borders of the visible iris diameter, you need to go larger. If 50% of the scribe or the entire scribe is beyond the borders of the visible iris, then you don't need to go with a larger diameter lens. The width of the scribe is 0.6 millimeters, so that gives you some perspective on how much larger you may need to go, especially when they're landing within the borders of the visible iris. Now, these scribes are only placed on the smaller 14.8 diameter diagnostics because in the larger lens, visible iris diameter rarely factors in. Now, in terms of diameter, you're not stuck with simply a 14.8 or a 16.3. You can flex the ICD FlexFit from a 14.8 down to 14.5 millimeters, or you can go up to 15.5 millimeters. So your diagnostic lens can be used as a starting point, but if you need slightly larger or slightly smaller, that can be done with your consultant. The 16.3 can also be modified in diameter. You can go down to a 15.5 or up to a 17 millimeter when you need to. Now, it's not very common to need to modify the larger 16.3. Generally, it's so forgiving as a large diameter that it's rare you need to change it, but it's there if you need it. Now, the larger 16.3 millimeter diagnostic lenses have a dual depth, or what you might think of as a toric landing. And the reason for that is, as you go closer and closer to the border of the visible iris or the cornea, the eye is relatively symmetric. So the closer you are into the cornea, the eye becomes, or the sclera is very symmetric in shape. So a 14.8 millimeter diagnostic lens is symmetric in your set. However, the 16.3 landing farther out on the sclera lands on more asymmetric or toric scleral shape, and therefore those lenses have a dual depth landing. Now, you can also construct either the small or the large ICD FlexFit as a quadrant specific lens, or what we call a sector specific landing. That means that you can make any one quadrant or up to 4 quadrants change in elevation. So your lens can be completely asymmetric around its circumference to best fit the eye. This is a nice option to have, but thankfully we don't have to use it too often. Generally, the standard 14.8 symmetric on when you need a smaller lens, or the larger 16.3 when you need a larger lens, has the right landing, appropriate for most eyes. Now, the ICD FlexFit lenses are also available in a multifocal lens when you need it, with most minus in the center, most plus toward the periphery. These lenses can work very well when you have a well-centered scleral lens. The apex of the lens will have the most minus, so if it centers over the visual axis, then you have the best hope of providing good multifocality for the patient. Now, the diagnostic set is labeled according to sagittal depth and not according to base curve. So consider the patient's condition when you fit the lens. Is it a normal cornea? Then you know the sagittal depth is relatively low. I need to go to the lower end of the fitting set. If I'm dealing with a bulging condition like keratoconus, I'm going higher up in the fitting set. If I have keratotic lobus or a bulging graft, I need to go much higher in the set. So you don't have to worry about what are the K readings, what is the topography. It's really what is the condition, and that guides your lens selection process. When you choose your initial diagnostic lens, it's therefore based on the condition and the most likely associated sagittal depth. So if we're using the 14.8 millimeter diagnostic and we have a normal eye with ocular surface disease, we will choose the 3400 micron SAG lens. If we're using the larger 16.3, we're going to pull a 4000 micron lens. That's the height for the normal eye. Notice as you fit a keratoconic patient, the depth of both the 14.8 and the 16.3 jump up 400 microns because the keratoconic eye is deeper. It's more bulging as a condition. Corneal transplants can really be virtually any height from sunken in to incredibly prolate. But as a starting point, it's always best to begin higher in height in the diagnostic lenses than what you really need. Better to have more apical clearance at the center than to risk having touch. Then you need to put on another diagnostic lens. Now there are various ways to apply the lens. You can use a suction cup, you can use a 2-finger method or a 3-finger method. Ultimately, we just want a stable platform to deliver the lens to the eye. We're going to fill up the bowl full of fluid and then instill our fluorescein and use a lot more than what you think you might need, knowing that the vast majority of that fluid and fluorescein together is going to end up on the floor when you apply it. Most of it is going to get squeezed out as the lens is applied. Now, if bubbles are present, the lens needs to be removed and reapplied. That area where you have the bubble is going to begin to create a dry spot for the patient, and that will become agitating over time. So if you have an application bubble, remove the lens and reapply it until you get a lens on without any bubbling. If a lens goes on eye and it hits the central cornea especially, then you want to remove that lens and put a higher depth lens on eye. The scleral lens must clear the corneal tissue. You must find the right height of lens for the height of the eye. Once the lens goes on eye without a bubble and without any bearing or any areas where it's thin, especially in the central 10 millimeters, then you can begin your assessment. And the first step is to determine if you have the right apical clearance. And we want approximately 300 to 400 microns of fluid on application. You want plenty of fluid between the lens and cornea to allow for that lens to sink and settle over time. So when in doubt, always shoot for more with your diagnostic lens. Now the optic section is what we really want to use, but an OCT can be helpful to provide you with perspective. Just be aware that the OCT wasn't designed to measure lens, fluid, and then cornea. So at times it can make mistakes in its estimation. So always trust the optic section. You know your diagnostic lenses are 300 microns thick. Use the known thickness of the lens against the fluid in behind to estimate how much that lens is clearing the cornea. So lens 300 microns or 0.3 millimeters thick, estimate that thickness versus the thickness of the fluid in behind. Now you want to start with an understanding of the fluid thickness at the apex, but also all the way through the cornea, running your optic section across the entire cornea. Here we can see the fluid thickness appearing much greater than the 300 microns of the lens. The fluid is at least double the thickness of the lens. Now, why do we want to start with more fluid than what we might need? Why 300 to 400 microns on application? And the reason is these lenses can sink and settle a great deal because they land on that very soft, spongy conjunctiva. You can lose up to 250 microns of apical clearance as that lens settles in. Typically, the settling is about 125 microns. So start with 300 to 400 microns knowing that on average you're going to lose about 125 microns. To assess this, it must have enough settling time. Use a minimum of 1 hour of settling time. If you can go even longer, all the better. And that will assure that as that lens sinks and settles in, it's not going to end up touching somewhere that you don't want it to. The ICD FlexFit has 4 principal zones, each labeled according to its function. The central clearance zone should clear the central cornea. Peripheral corneal clearance zone should clear the peripheral cornea. Limbal clearance zone needs to, of course, clear the limbus. And finally, the scleral landing zone is the only part of the lens that should touch down. So your ICD FlexFit should vault through the cornea, through the peripheral cornea. Then the limbal clearance zone will link up the vault in the far periphery to the landing of the lens out on the conjunctiva. When you make your observations post-settling, the first thing you want to look for is, does my lens clear through the central cornea? Does it clear across approximately 10 millimeters of the center of the lens? Ideally, we want post-settling about 200 to 300 microns of fluid thickness. But if you prefer to fit your lenses with less fluid under the center or more fluid, you can do that. The ICD FlexFit can be manipulated to create any vault that you desire in the center. Now, if the lens has gone on eye with inadequate clearance or excessive clearance, you can always go to your trial set and go up higher in sagittal depth or lower in sagittal depth as you require. If you've placed on eye a 4400 16:3 lens and it has only 90 microns of apical clearance, that might not be enough to allow for the settling. So go up from 4400 microns, 200 microns to 4600 microns. You're now adding 200 microns of vault under the center. We should have 290 microns of vault in this case. Now the next zone out in the lens is the peripheral corneal clearance zone. And all we're looking for here is that lens appears to clear through the peripheral corneal tissue. Then we go out in the lens to the limbal clearance zone. And of course, what we're looking for is, in white light, the fluorescein appears to run past the peripheral cornea onto the initial part of the conj before being squeezed out 360 degrees in the landing zone. And that, of course, brings us to the final zone in the lens, where we want to see that lens landing itself down in an absence of fluorescein, 360 degrees around, and a healthy vessel supply through the lens edge. When you observe that lens post-settling, one of those important observations is to determine, did that lens come in at a very steep angle? Does the lens point into the surface of the eye rather than pointing along the surface? Is it so tight that it's going to cut off the vessel supply? If we have the right relationship of scleral landing zone to underlying scleral angle, then the lens should point along the surface, not into the surface, and that should create a much better landing at the tip of the edge and allow for the small and large capillaries to run past the edge in a healthy manner. Now the ICD FlexFit larger lens, the 16.3, has 2 scribe marks 180 degrees apart. They denote for you the flat meridian of the back surface of the lens. When those scribes are rotationally stable, regardless of where that is, they can be any axes. They're not meant to be just at 0, 180, but they can be virtually anywhere. If, however, they're rotationally stable, then you know you likely have the right matching of back surface toricity of lens to toricity of scleral shape. The second thing those scribes tell you when they're rotationally stable is whether you can add a front toric lens. If you need to add toricity to the front, can you assume it's going to stay on the axis you desire it to be? So when a front toric lens is required, make sure you observe where those markers settle to. Then rotate the lens 90 degrees off axis and see if they come back to the same resting point. If they do, you know you can add the front surface cylinder when you have residual astigmatism. Now moving forward with the ICD FlexFit, just get comfortable with the various zones. Central clearance zone should clear the central cornea. Peripheral corneal clearance zone, if that lens is landing down on the peripheral cornea, that's the area you need to modify. If the lens is hitting at the limbus, if it's hitting a little bit of peripheral cornea, hitting the limbus and landing on the initial part of the sclera, then you know you need to alter the limbal clearance zone. If there's a problem with the edge, then that's an issue with the scleral landing zone. So each zone is labeled according to its underlying anatomy and tells you where the modifications need to be made. And therefore, what do you discuss with your ICD FlexFit consultant? So in summary, what you want to consider is putting a lens on without any apparent thinning or definitely without any touch. The lens should go on eye and completely vault through central cornea and peripheral cornea. Then observe the landing of the lens toward the peripheral cornea and limbus. It should not be touching itself down. It needs to clear through that peripheral cornea and limbus. If it lays itself down, if there's greater than 180 degrees of thinning, this is likely to be a problem and will almost certainly cause some staining after settling. However, if you see less than 180 degrees of thinning, then that's typically just the slight decentration that we see with scleral lenses. But if you're in doubt, have the patient wear the lens for a number of hours. Then remove the lens, stain the cornea, and if there's nothing here where you see this thinning, then you know it's just thin fluid but not actual bearing. Now post-settling, what we want to ensure is that that lens edge does not land in such a tight manner as to cut off the vessel supply. We want a healthy edge to surface relationship, allowing for the small and large capillaries to run right past the lens edge. So when you receive your ICD FlexFit diagnostic set, consider the 14.8 for more regular eye shapes and smaller corneas. If it's an astigmatic eye, then that might be a patient that has less irregularity and a good candidate for the smaller lens. If it's a small cornea as well, then certainly the 14.8 is the right choice. If you have an oblate post-refractive surgery patient, they tend not to be bulging eyes. You may be able to fit that patient with a 14.8. If it's a normal cornea with ocular surface disease, and again, a small cornea, then this is a good candidate for the 14.8. And additionally, if you have the deep set eye or a patient that's struggling with application and removal, consider the smaller lens. But when you're dealing with more irregularity, then you want to consider the 16.3 diameter ICD FlexFit. A bigger lens will have an easier time vaulting the irregularity. So your lens of first choice should almost always be the 16.3. But then when you consider the smaller eyes or less asymmetry, then it might be possible to use the smaller diameter diagnostic. Now, I hope this video has been helpful, but if you have questions, contact your Precision Technology or Cardinal contact lens consultant. They're the exclusive manufacturers and distributors of the ICD FlexFit in Canada. Thank you very much.